In this lesson, we're going to be factoring by grouping, the method that we use when we have four terms as far as factoring polynomials. I'm going to do a couple examples to start off that kind of is the main step of factoring by grouping, and so you can see how that works. And then we'll do some examples with the actual four terms. So if you look here at number 1, you'll see that I have 2 times the quantity c plus d minus b times the quantity c plus d. So it's not a typical polynomial written in simplified polynomial form, but you will notice that I have the c plus d and the c plus d in both of those terms. So what I'm going to do here is I'm going to factor out just like I would if I had something like 2x minus bx. If you look at that problem, you can see that I have x and x in both of those terms. So I would factor it out like a GCF, and I would get x times the quantity 2 minus b. I'm going to use that same process here. I have c plus d and c plus d. So c plus d is like some x. We don't know what it is, but it is the same. C plus d is some value. And that is going to be multiplied by 2 minus b. If I take this and I distribute the c plus d times 2, I'll get my first term here. And c plus d times negative b will give me the second. Now this is considered factored. The only difference between this, if you look at the original problem, you may say, well, this looks factored as well. But I do have that minus that is in between the c plus d and the minus b. And so that means it's not actually a product. I have 2 times the quantity c plus d minus b times the quantity c plus d. Where in the second example here, where my answer is, I have the quantity c plus d times the quantity 2 minus b, which is considered a product. In this next example, you'll see that I have b minus 1 and 1 minus b, which aren't exactly the same. But I can make them the same. If I take this problem and I rewrite the second half, instead of having a minus 5, I'm going to put a plus 5. And then what that will do is I can switch this around. I'm basically taking the b minus 1, or the 1 minus b, and multiplying it by negative 1. So that would give me a negative 1 here and a positive b here. I put it in this order so it looks the same. Okay. If I distribute this 5, I get 5b and negative 5. Where here I'm going to get negative 5 and positive 5b. So it's equivalent. And now I can follow the same steps that I followed in the last problem. And I come up with this as my factored form. Okay, so this is just kind of leading us into what we're going to do with the factor by grouping. So here's an example of a 4-term polynomial that I'm going to use the factor by grouping. Now, I'm going to try, we always should try the factor by grouping. It is the method that we use with 4 terms. Sometimes it's factorable and sometimes it's not. In this case, it's going to be factorable. I'm going to look at my first 2 terms, and I'm going to look at my second 2 terms, and I'm going to factor out the GCF. So here I can take out a p squared, and I have p minus 3 left over. Here I can take out a 2, and I have p minus 3. So now I have the p minus 3 in common, so I'm going to factor that out, and I get p minus 3, and then p squared plus 2. This is considered completely factored. Some of you may look at this and say, well, I have a p squared here, but I don't have my minus, and this is not a perfect square, so I'm not going to be able to keep factoring this. Can I check this? Sure. If I go back and I FOIL this out, I'm going to get p cubed plus 2p minus 3p squared minus 6 when I do my first, outside, inside, and last. And you'll see that this answer, even though it's in a little different order, is the same as what I started with. Okay. The next example, I'm going to take out it. I'm going to do the same thing. Pair up the first 2 and pair up the second 2. Here I can take out an a, and I have a plus b. Here I'm going to take out a negative c. Be careful here, because I am factoring out a negative c, which means that I'm going to get an a here, but this is going to actually be a plus b. So when I distribute this negative c, I get negative ac and negative bc, which is exactly what I should have come up with. Okay, so now I have the a minus a plus b and the a plus b in common, and I'm going to get a plus b times the quantity a minus c. Once again, you can check this one by multiplying it back out, and you'll see that they're equivalent expressions. And here my last example of the basic type. I'm going to look at the first two and the last two, and I can take out an n squared, and I get n plus 2. Here I can take out a negative 4. I have n plus 2, so I have my n plus 2 in common, and I have n squared minus 4 as my second factor. Now you'll notice n squared minus 4 is our difference of squares. So I'm going to be able to actually factor this a little bit further. I have n plus 2, and then n minus 4 is going to factor as n plus 2, n minus 2. I can either write my answer in that form, or I can write it as n plus 2 quantity squared times n minus 2. Both of them are considered factored. In this next example, I'm going to factor as a perfect square trinomial, then a difference of squares. So instead of pairing it as 2 and 2, I'm going to actually pair it as 3 and 1. So what I have here is I'm going to look at this, and I'm going to look at this by itself. Okay? Those first three, the reason I'm pairing them together is because it's actually a perfect square trinomial. So I'm going to be able to factor it as x minus y quantity squared. And then I have the minus 4. And then if you look at this, this is similar to something like if I had a squared minus 4. I could factor that just like in the last example, and I would just get the a plus 2, a minus 2. But instead of a, I have x minus y. So I'm going to do the same thing, but I'm going to have x minus y and x minus y plus 2 minus 2. We generally don't have the parentheses within the parentheses. We try to get rid of that. So an easier way to look at that would be written like that. Now this looks a little different because I don't just have a binomial times a binomial, but it is a product. It is considered factor. I just have trinomial times a trinomial. In this next example, I'm going to do the same thing, but this time when I look, I'm going to look at kind of my variables. I have a t squared, a ts, and an s squared. So that leads me to believe that these are the ones that I'm going to pair up. But when I do so, I'm going to have to be careful because I'm going to have a minus, and then I'm going to actually look at this as that problem and put that trinomial in parentheses. I factored out a negative 1, which changes my signs. So when I factor that as a perfect square trinomial, I'm going to get t plus 2s quantity squared. And then I can factor this as a difference of squares, and I'm going to have 3p plus t plus 2s, and then minus t plus 2s. Okay, so in my final answer on this one, I'm going to be able to write this one as 3p plus t plus 2s times the quantity 3p minus t minus 2s. And this would be considered my factored form.